You may. Is it gonna let me scroll my screen? It's gonna be like this, is it? There we go. Okay, guys, can we jump to page... What's the page after where you were? 24. So for this one, guys, we're finding the rule of a periodic... You didn't bring yours? I'm pointing at it. Below. Why have you brought last units? Okay. So, like I said, guys, we normally start with a rule and then work backwards. Sorry, we work forwards to write the graph. Today we're going to be starting with the graph, working backwards to figure out the rule. So, we talked very briefly the other day, how come like C always has like, it's like pi on 4, pi on 2, whatever. We're going to be seeing an example today where it's not that. And you'll sort of see how that works in this situation. So we're going to extrapolate a rule to describe height of the tide over time in the form of y equals a sine bx plus c plus d. Now, I've obviously told you that we're using sine for this rule. Could we use cos? Yeah, sine is just cos with a phase shift. So we could make an identical cos rule, but it would just have a different phase shift, a different c value, and then it'd all work out fine. Cool. So guys, we have 4 things we need to find. We need to find my A, my B, my C, and my D. What do we want to find first?
DNA.
DNA? Jeez, well, I'll get the blood tests. That was a bad joke. Even as I said it, I realized that was horrible. Okay. Well, DNA, so those are both to do with vertical shifts and stretching vertically. So, what do we think, guys? How would we go about finding either the D value or the A value? Okay, so you've jumped ahead like that's flagrantly obvious. How do we know that the median value is 5? Yeah, it's halfway through. And you can sort of see visually, if I put a dashed line across at 5.
People amplitudes get above the drop.
Yeah. So just visually, can you see that the median value of that function is 5 meters? So, because it's the height of water, so I don't know that it's meters. Doesn't make sense for it to be centimeters. Doesn't make sense for it to be kilometers. It says in Cleveland Bay, which is in Australia, so it's not in feet. We'll assume it's in meters. But it's a very good point. We don't know that for sure. Doesn't matter what measurement it really is in. But yeah. So visually, median value is 5. So therefore, D equals 5. So I'm just going to keep a running tally. That means our rule must be y equals a sine bx plus c plus 5.
It's 2x because it does things.
I don't see pi on those x-axes. It does 2 loops in 24 hours.
We call that 3 pi.
Nope. We'll get to that in a minute. There will be pi's in the rule. There won't be in our values. So we've got our median value. We just need to figure out our amplitude. So, do you think our amplitude is going to be positive or negative? Are we starting near a peak or starting near a trough? Near a peak. So would that make if this is a sine function, yeah, make it positive. So, how big is our A value going to be? 2.5. So the peak slash trough is 2.5 away from the median value. So therefore, sorry? Because if you look, our median value is here at 5. Our peak is at about 7.5. The trough is about 2.5. So both of those are 2.5 away from the median value, which is all that A tells you, how far away from the median value it is. So A must equal 2.5. Okay. So therefore our rule is y equals 2.5 sine bx plus c is 5. Now we have 2 letters remaining, B and C. Which of those do you think is easier to find? The phase shift. It's a 50-50 shot, and you were not correct. Can anyone tell me why you can't find the phase shift yet? You need B. You need the B value, because remember our phase shift equals C over B. So to figure out C, you need to know the phase shift and you need to know B. And we know what the phase shift is. Like, we can look at that from the graph, but we don't know what B is yet. So we're gonna have to find B. What information do we know that we can use to find B? Yeah, the period is 2 pi over B. So I'm just going to do this over here. We know that the period was 2 pi over B. Now, the period's not as obvious because we're not starting at a critical point on this one, which makes it a bit of a hassle. But in that 24-hour period, how many full revolutions do we do? 2. So we start, if we start at this peak, we do a full one over to this peak, then we do almost a full one over to the next one, but we have that little bit at the beginning as well. So that should be 2 full revolutions in 12 hours. So in 24 hours. So if we do 2 full revolutions in 24 hours, what is the period?
101.
How many hours does it take to do a full revolution? 12 hours. So my period is 12. Does that make sense, guys? The period is how long it takes to repeat itself. If I look here, one way to go from the period is you measure from peak to peak, or you measure from trough to trough. So because that'll be when the function has fully repeated itself. Can you see it here at like 1.5? By the time we get back to a peak, 13.5. What's the distance between 13.5 and 1.5? 12. So my period is 12 equals 2 pi over B. Rearrange that, times B on both sides. We get 12B equals 2 pi. Divide by 12 on both sides. B equals 2 pi on 12, and I'll just simplify that to pi on 6. Questions, comments, concerns? We're fine with how we got pi on 6. Okay, so let's add that into our rule now. So that means our rule is y equals, what was it, 2.5 sine pi on 6. I just like to put that in brackets just for clarity. Times x plus c plus 5. Okay, well, all we've got to do is find our c value now. So I'm just going to go down here. What's my rule for phase shift again, guys? Negative c over b. Now, this is actually a little bit trickier than it seems. And there's more than one answer. There's technically infinite possibilities of what c is, but we try and choose the smallest one we can. Can anyone tell me, has my function been shifted left or right? You could go either way, but what does a sine function normally start at? 0. If it's been shifted to the right, that means it's been shifted 4.5 hours to the right. If you wanted to go from the left, can you see that there's if you continue that down, there'd be a leftward shift that's a bit smaller. Then you can solve it either way, you get the right answer. I don't care about that, but we generally want to try and do it as simply as possible. What would that shift be to the left? We know our period is 12 hours, right? If this is a sine curve, and I know that my peak here is at 1.5 hours. Now, if we do a sine curve, just looking at the axis, it's halfway between 1 and 2.
Oh, yeah.
If we are doing a sine curve, what percentage of the way through the sine curve does the first peak happen? Like, is it halfway? Is it 3/4 way? That sort of thing. The first peak. It's a quarter of the way through because there's 4 critical points basically. There's midpoint, peak. So that's the first quarter, peak to midpoint, second quarter, midpoint to trough, third quarter, trough to thing, fourth quarter. So we know that the period is 12. We know the peak should be occurring quarter of the way through that. What's a quarter of 12?
3.
3 hours. It's occurring at 1.5 hours. So could we say that the phase shift, it is moved left 1.5? Is that accurate?
Yeah.
Do we get where we've gotten that left 1.5 from, guys?
Could you also do a visually?
Okay, well let's do that.
See where it starts to go down.
So we agree that the period is 12, so it's going to do one full revolution from there to there, right? We also know that sine starts at a midpoint, and then it goes to a trough, then to a midpoint, it goes to a peak, then a midpoint, then a trough, then a midpoint. Halfway along that would be 6, halfway along that would be 3, halfway along that would be 9. So without any phase shift, we would have so that red line there, guys, that would be y equals 2.5 sine. What do we say b was? Pi on 6. Times x plus 5. Do we agree that that red line is that everything the same as the original, but just with no phase shift? And you can see pretty clearly from that the green line is just that line, but shifted left a little bit. To ever find phase shift, all you got to do is find the distance between like points, so from the peak to the peak. So you see that peak is at 3. It's now occurring at 1.5, so it's 1.5 to the left, minus 1.5. That's all it is. I guess this is why I always leave phase shift for last, guys, because it involves B and C. There's a bit of mucking around to figure out what it actually is. Like I said, you could also do it. You could also say, well, this is where I want to. That point there is where I want to start. So you could do the phase shift of, that many hours. You can do whatever phase shift you want, and it should work out. But I like to just do the smallest one possible, just to make it simple. Okay, so we know that, what colors are using green? We know that the phase shift is negative C over B. My phase shift is to the left, so is that negative or positive? Negative, so I have negative 1.5 equals negative C over, and what was my B value? Pi over 6. So what I'm going to do, how would I rearrange that to find C, guys? Oh, you can't do that because we don't know what C is, but yeah, we can times both sides by pi on 6. Times pi on 6 over here. times pi on 6 over here. And that will give us negative 1.5 pi over 6 equals negative c. Can you see that we have a negative equaling a negative? So we can pretty much just cancel out the negatives. So I'm just going to cancel out those negatives here. If maybe I'm not, because my eraser's playing up again. So 1.5 pi divided by 6 equals c. You'd be well in your rights to leave that there, and if you gave me that on the exam, I would give you full marks. I don't, it hurts me as a maths teacher to leave a decimal on a fraction. It's just not the way things should be. How many times does 1.5 go into 6? 4, because 1.53, 4.56. The other way you could have done that, 1.5, if I just double it, I'd get 3. Double the bottom, I'd get 12. 3 divided by 12 would be 1 over 4. So we can just rearrange that on the bottom. C equals pi on 4. Okay. Which gives us our final rule, guys. Y equals 2.5 sine bracket pi on 6 x plus pi on 4 plus 5. So in answer to your, I think Cody, you said before something about like, will there be pi's and stuff in this one? Yes, but only in the rule, not on the graph. Basically, if your x-axis is in pi on 2 pi, whatever, your rule is a lot nicer. If your axes are in everyday units, so like meters, seconds, minutes, whatever, your rule tends to be a bit more ugly. It has pi's and stuff in it, which makes it a little bit harder. Honestly, it's just something that comes with practice. Like, when we do these problems, you just have to look for opportunities to simplify stuff. Like I said, if you left it at 1.5 over 6, full marks. I'm not going to ping you for not knowing that, That's a hard question to answer because not for doing that. However, if you simplify your fraction, it's easier to see if other stuff cancels out as well. So you might have like a divide by pi on 4 later on or something, which then cancels the whole thing out. But if you hadn't fixed it up to be, if you left it as 1.5 pi on 6, you wouldn't notice that those two things do cancel out. So you're more likely, I suppose, to get more marks, but there's not specific marks for doing that, if that makes sense. Guys, I want you guys to have a practice at these. So there's some questions like this on page 544 of your textbook. I'm trying to remember these questions. I think they're all right. They're similar to this, where you start with the graph and you solve from there. So